All right, so these were the two videos, the two problems that I had you do in your Canvas. Let's go ahead and do them. We've got this distribution that needs to happen on the outside first, so we're going to distribute the 2. That gives us 5z minus 2 equals 6z minus 8. I'm going to get the variable terms on the same side, so I'm subtracting 6z. Notice I'm doing the opposite here. That's going to give me negative z minus 2 equals negative 8. Then I'm going to add 2. That gives me negative z equals negative 6. And then I don't want negative z, I want positive c, so I'm just going to switch the signs. Z equals 6. Second problem over here, we're going to distribute the 2/3. Left side of the equation stays the same, but 2/3 times 6y gives me 4y, right? Remember, it's 2 over 3 times 6 over 1. That's 12 over 3, right? 4, just so you can see it. 2/3 times 15 is going to be 10. 2 times 15 is 30, divided by 3 is 10. Now we've got an equation where we just got to move it over. I'm going to subtract the 4y from both sides. That moves the variable term over here. And then I'm going to solve it like I have been solving them. Divide everything by 4, and we're done. All right. If you got these problems wrong, this was your check for understanding. You need to go back and make sure you understand it. Leave a comment with questions. Seek out your teacher, right? Talk to somebody, make sure you figure that out. Let's go back, move forward and do our last 2 examples here. We've got a good word problem here. So let's go ahead and start it. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold by the dealership has been increasing by 6 cars each year. So that's the new cars sold have been increasing by 6 cars each year. The number of used cars sold by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? Ooh, okay. So there is a lot to unpack here, right? So let's kind of think about what's happening. We're comparing new cars to used cars, okay? And in the end, we're finding out when does the new cars be the same as twice the used cars. So we've got an equal sign being said there, right? When will this be the same as twice this? So we've got new cars over here, and we've got twice, so 2 times the used cars over here, right? See what I did there? Okay, we're seeing when is the twice the used cars going to be the same as the new cars. So I need an expression that represents what's happening to the new cars, and I need an expression that represents what's happening to the used cars. So what's happening to the new cars? There's 78 sold, and then it's increasing by 6 per year. 78 sold plus, because it's increasing, 6 per year. We don't know the number of years, though, right? In fact, that's what we're looking for. How many years? So x in this case is going to be years. Okay, then that's going to be 2 times, and then what's happening with the used cars? We have 67 used cars, and it's decreasing by 4 each year. Wow. All right, it looks like I've got an equation now, right? I took what was happening with my new cars, and I represented that with an expression, 78 plus 6 per year. And then I took what was happening with my used cars, 67 minus 4 per year. But I multiplied that number by 2 because it's twice the number of used cars. So let's go ahead and solve this and see what we got. This we got to distribute the 2 first. 78 plus 6x equals 2 times 67, which, let's see, in my head here, that's 134 minus 8x, because I got to multiply the 2. Let's get the variable terms on the same side. I'm going to add 8x to both sides. That gives me 14x. 78 plus 14x equals 134. And then I'm going to go ahead and subtract 78, giving me 14x equals, let's see, 134 minus 78. Minus 8 gives me 126. Minus 70 gives me 56. Does that sound about right? I think that sounds about right to me. Then we got divide both sides by 14. 14, 28, 42, 56. Looks like that's x equals 4. So it's 4 years. In 4 years, the number of new cars sold will be double that of the used cars sold. We're going to do one last example. Word problems, by the way, are the hardest part is creating this equation, right? But the best thing you can do is just try to make sense of it. Like, what is happening? I highly suggest you underline important parts in the problem, and try to link those things together. The hardest part is translating the English to the equation. Okay, that takes practice. So we'll see that in our homework tonight as you do a couple of these. All right, but let's do our last set of examples. The last set of examples talks about the number of solutions. Anytime you get x equals a number, right here, that means that there's one solution. So everything we've done thus far has had one solution. But as it turns out, we can actually have equations that are different. So let's solve those and see what happens. So 3x, we're going to distribute that. We get 3x equals 3x plus 12, right? But watch what happens here. When I subtract 3x from both sides, on the left-hand side, I get 3x minus 3x, which is 0. And on the right-hand side, I get 3x minus 3x, which is 0, which leaves just 12 on the right side. So I have this weird thing that says 0 equals 12, but 0 doesn't equal 12, right? 0 is 0, 12 is 12. This is a false statement, right? It is a lie. When this happens, when at the end you've canceled the variables out on both sides and you're left with a statement that is false, it means that there's no solutions. It means that there isn't a number that I can plug into this to make it true. When this is false, there are no solutions. Now this one on this side is actually going to turn out different. We're going to distribute the 2. We're going to get 2x plus 10 equals 2x plus 10. If you notice that those things are the same on both sides, well, what's going to happen when I subtract 2x? That cancels, and I get 10 equals 10. This is true. 10 is, in fact, 10. But my variable disappeared, so I don't know what x equals. Well, as it turns out, when you end this with a true statement, what it means is all real numbers will be solutions. It actually doesn't matter what number we plug into this. It will always make a true statement. If I were to plug in 3, this would be 6 plus 10, 16. This one would over here would be 6 plus 10, 16. It'd be 16 equals 16. If I plug in 0, it's 10 equals 10. If I plug in 1, it's 12 equals 12. It doesn't matter which number I plug in. It's always a true statement. So this answer becomes all real numbers. So, moral of the story. If you're solving and you get a false statement, it's no solution. If you're solving and the variable disappears and you get a true statement, it's all real numbers. If you're solving and you get something that says x equals 5, there is one solution. Like, that's what we've been doing. Okay? All right. And that's it. That's the end of chapter 2.5. We've got an assignment for you up on Canvas, so go check that out. As usual, questions, comments, concerns, you can leave them in your comments. Or, most importantly, go seek out your teacher, right? That one-on-one is very, very useful. So, have a great time. Thank you very much for watching, and we'll see you again.